our unit 1 of our financial modeling course. Session 4 of our unit 1 deals with the assets, prices, and returns. At the end of this session, you should be able to distinguish between weighted average of simple returns and simple returns itself. And you should also be able to calculate excess returns of assets. And finally, you should be able to compute returns using EViews or Excel spreadsheets. Weighted average of simple returns is a simple returns on a portfolio of assets other than on an individual asset. Here the focus is on the portfolio, that is a cluster of individual assets other than just a single asset. It is prudent to also understand that log returns cannot be employed in weighted average of simple returns. This is because the log of sum is not the same as the sum of log, given the non-linear nature of log transformation. What we are saying here is that in transforming data or prices into returns using log transformation, we are saying that the model of computation is non-linear. Therefore, we cannot transform data, or we cannot compute the log returns on the weighted average, given that the weighted average has to do with the summation of all the price series for the individual assets in the portfolio. So we are looking at the portfolio as a whole rather than looking at individual assets. So the weighted average of the individual assets is given in equation 1.8. Here what we are saying that RPT, or the R, is the return of the price. Here we are looking at the return of the price but not individual price. So portfolio, so the return of the portfolio of the individual prices, which is equal to the summation of both the returns and the weight given to the return. The W1 has to do with the weight which we assign to the return, and the R has to do with the return itself. Here we assuming we have 5 assets in a portfolio. The W is simply saying that we have to assign to this individual asset weight based on the proportion of our investment in those assets. So let's say we have stocks, we have bond, we have other financial assets in a portfolio. We assign to them weights based on how or the level of investment in that asset, making the portfolio. Assuming we are considering only stocks, then the total return from such stocks or assets is the sum of the capital gain and dividends paid during the period of holding such assets. With capital gain, we are looking at the level at which the price of those stocks increase over time. So let's say you bought a stock at, let's say, 20 cedis today, and tomorrow it has increased to, let's say, each price has increased to maybe 25 cedis. What we are saying is that the capital gain is the differences in the price of the stocks or the stock or the asset. So when we talk about capital gain, it has to do with changes in the price of the asset that you are holding. So if it's increased, the price are increasing, and you are gaining something, or we term it as capital gain. Dividends is supposed to be considered in our calculation of returns. It is relevant to understand that ignoring dividend payment in the computation of returns leads to an underestimation of total returns to investors. It is very true, because it has been established that the total returns to an investor for investing in a particular asset has to do with both the capital gains and the dividend which is paid. But in most of the times in computation or in computing for returns, we only consider the capital gain, which is the changes in the price series. Alternatively, it is possible to adjust stock prices to account for dividends in order to avoid underestimation. Here we are saying that it is possible. So with some stock price or with some data on stocks, we have the adjusted price, which has to do with we adjusting the particular price of that share on a particular day, given the announcement of dividends. Return series. Before we formally consider the issue of stationarity and non-stationarity of financial data sets or financial data, we can make a qualitative adjustment of the graphs of the price series in figure 2 and 3 and also compare them to the return series in figure 4 and 5, because we said that the price series are not stationary compared to the returns, and also we term these properties or the property of the return series over the price series as stylized facts. So we are saying that even graphically, without we computing it or going through any series of computation, we can compare the graphs, or pictorially we can compare the price series and the return series, and also we convince ourselves that the price series are non-stationary compared to the return series. So graphically we consider that in figure 2 and 3 and also 4 and 5. It could be observed that both figure 2 and 3 are non-stationary as depicted by the upward trends, as we saw earlier in our slide in session 3. We realized that the price series were not stationary, given that they were having upward and downward trend, which was constant. So the constant fluctuations, the up and down movement in the prices, as we saw in figure 2 earlier. So converting prices into return series can also result in stationarity. Here what we are saying is that it will be prudent to compute or to estimate models using the price series, given the non-stationary nature of price series. Therefore, there is a need for us to convert those price series into return series, which are mostly stationary. This also indicates that the quality that return series possesses over price series in quantitative analysis, which we have already considered in the other session, and we have termed as stylized facts. So figure 1.4, as we have here, has to do with the return series of RLG. The returns start from 2011 and ends at 2013, and these are the log returns. Unlike the price series that we saw, which started from 1,000 units to 2,000 units, which has this constant fluctuations, the return series, as we see in figure 1.4, does not possess such quality. Here, what we are seeing is some series of volatilities. Here, the upward and downward trend are in this mode, other than the price series, which has this trend like a moving trend, the upward and downward moving trend, which has not come back to stationarity, that is 0, or the average, which is the 0. Yet the log returns has these properties of clustering, as we earlier said. So this price series, this here, we term this place as clustering. So when we earlier spoke about volatility clustering, this is what we mean by the return series possessing volatility clustering. So all these areas indicate that they possess volatility clustering. What we are simply saying is that at this place, there was increase in the increase in the return series. Let's say from 0.00 to 0.2 around here. Then on the previous day, there was also an increase. There was also an increase, like a continuous increase. And when there was a downward, like a decrease, the following day was also possessing or was also having the same downward trend or the downward movement, which indicate that with the return series, when there is an upward trend, or when there is a higher volatility, it will be followed by a higher volatility, and when there is a lower volatility, it will also be followed by a lower volatility, which we term as the volatility scatter trend. So you can clearly see that the return series are quite stationary, they are quite stable, they are mostly around the center, which is the 0. The upward and downward trend lags. For instance, this one, it lags between 0.03 and -0.002. So it's quite stationary compared to the price series, which start from 1,000 units to 2,000, and even with some stock, it's even above. The diagram I have here with me has to do with the eViews. So this is the eViews application, the tool or the statistical tool or software that we use in generating or computing returns, and also other estimating models. So here, for instance, we are using the eViews to generate return series from the price series. So you could see that we have here with me a platform or an interface which has series of icons, which has, for instance, in our case, we have file, edit, object, view, among others. All these icons or the menu bar has its own purposes. In our case, we are simply generating returns. So here we focus on this diagram where we focus on this arrow, or the portion of the diagram with an arrow here with an arrow, and we could clearly see that this is connecting us or asking that we should generate something. So to generate new quantity, so here when we go to generate, this additional box or dialog box pops up. Here what we simply see is that RG, which is the return series of the stock price on the Ghana Stock Exchange, is equal to GH, has to do with the current price series here, current price series, and GH minus 1 has to do with the previous price. So it could be, if it is daily data, we are talking about GH will be the price today, and GH minus 1 will be the price yesterday, all over GH minus 1, which is the same price yesterday. So here we have a sample of 3,914 observation. Actually, this is a daily data, so it's a high frequency data, as we established in our earlier session. So this is a high frequency data. So here we are talking about here, so 3914 data set. So here we are saying we are going to calculate the return. So after entering this equation or this equation into the dialog box, we are good to go. When you click OK, here at this junction. When you click OK, given that you have already loaded your data set into the eView, so I think the first thing to consider after opening the interface is to load your data. So the data loading has to do with this portion. So here, these are the data. We have a data title C, DGH, GH, you see where and year. What you notice from this portion is that we have selected DGH, GH, and residual. That is, the selection has to do with the mark within the small boxes. So you could see that the GH was selected, which is the actual data which is going to be used in calculating or computing the return series. So after selecting this data set, then we come to the equation side, where we enter this equation which tells us that the eView should calculate the returns for us using this mode of calculation. So here we have said that our return series should be equal to the price of the stocks at the current date less by the price of stocks from the previous date all over the price from the previous day. So this is the equation that we are going to use in calculating our returns, as we saw in our earlier session. So this is the equation. So after clicking OK, then all these price series are now going to be converted into return series. So they will no longer be in the 2000, 3000 and thousands, but they will be in small units like decimals, 0.0 something, 0. So equals, and sometimes they are even negative, indicating that return series has a property, I possess a good property over the price series, that they are mostly stationary. They hold around the 0 line. So after calculating the return series using the equation that we saw in the other slide, that is the RGH is equal to the GH minus 1 all over GH minus 1. That is the equation that we saw earlier. After clicking OK, this additional box or this additional data set is created. We could clearly see from the earlier diagram that we only had C, D, GH, GH, you see the word and the E, but not the RGH. So the RGH is simply the additional data set that we created, which is the return series that we created from our price series. So we could clearly see the RGH with this, which is being indicated by this arrow, indicating that our data has been saved on our eView application using the difference in the equation. That is the equation that we computed, or we inserted in the additional dialog box, which popped up in our earlier diagram. So we could see that in eViews, the computation of return series is not as difficult as we think, because from our earlier submissions or our earlier sessions, we made it clear that none of this, or none of the computation of the model estimation is going to be done manually. We have applications that are going to help us, or we have tools that are going to help us in computing them, because manually we cannot calculate all this as easy as the eViews did for us. After getting to know the normal returns, like the simple returns, the weighted returns, and among other forms of returns, that is series of transformation of price series. Here we have excess returns. So by excess returns, we are simply considering the differences between the return on a risky asset and the return on some benchmark assets, which we mostly refer to as the risk-free, which has been labeled by, or which is being represented by the RF. So the difference between the returns on a risky asset and the return on a benchmark asset, that is mostly non-risky asset, is known as excess returns. Mostly we consider risky assets like investment in stocks or bonds, or even investment on the foreign exchange market. They are mostly risky in the sense that our returns or our profits are not assured. They are mostly not guaranteed. There is a chance of we even losing our investment altogether. So mostly we consider them as a risky asset, but mostly they also come with higher returns. In the event that it is doing well, there is higher returns. So the difference between these two, risky and non-risky assets, is what we call the excess return. So the equation for the excess returns is given as ZC, which is the excess return, is equal to RT, which is the returns on a risky asset, and the RF is the return on risk-free assets. Mostly we always consider a risk-free asset to be asset like, or we mostly consider investment in government bond or government like the treasury bills as risk-free. So the rate on the treasury bills are mostly regarded as the risk-free rate, which is this RF, are mostly regarded as the risk-free rate. So we are always of the view that government will not default. Regardless of what happens, government will not default. Therefore, investment in government assets, or let's say bonds and treasury bills, are considered as the risk-free. So the RT and the RF are return on risky assets, which is the RT, and the RF is a return on risk-free asset. So the concept of excess returns also has its foundation or basis from the concept of capital asset price model. So with the capital asset price model, we are simply considering how excess returns are being calculated, and we are considering like the riskiness of a market or of a particular market. This idea of capital asset price model will be dealt with in details in our subsequent sessions. In this session, we have discussed the weighted average of simple returns, and we have also differentiated weighted average of simple returns from simple returns, and we have also given a reason why we cannot compute the log returns on the weight of an asset as a weighted returns or the weighted average returns. So we are saying that we cannot, we earlier said that we cannot compute the log returns. We have given reasons for that. We have also illustrated how to calculate returns with the e-use application, which we made clear that it is quite simple compared to doing it manually or even using other applications. And we have also considered excess returns, which we said is the difference between the risky returns on risky assets and also returns on non-risky assets. In our next session, we will consider the idea of the efficient market hypothesis and predictability. Thank you.